So I tried to do that, and the SOBs, sorry, the whatever people, stopped letting us use codes. So I'm like, how am I supposed to do that? But what I found was, if I go to Chrome and on my phone and try to input the link on Chrome on my phone, it automatically pulls me over to the Jamboard off the link. So try that, because that worked for me on my phone. I was like, so go to Chrome on your phone, input the link to the Jamboard on your phone, and if you have Jamboard, the app installed on your phone, it should say, would you like to use it in the app or in Chrome? And then you stick the app.
Oh, okay.
Yeah.
Because I can get it, it's really, like, laggy, it's really slow. So I wanted to use the app.
Yeah.
It wouldn't let me do it. It's just
right. And I Googled like crazy trying to figure out how to get a code, and they stopped. They have disabled codes now. So now we can't do a code. So I kind of complained about that. But it looks like if you try to use go to a Jamboard on your phone, it should give you the option to automatically go straight into your Jamboard app, your Jamboard app. Does it not do that?
Thank you.
Yeah, sure. Okay, cool. So we are here talking about relative frequency. We did that already. Great. So now let's talk about cumulative frequency. Cumulative frequency. Let's get a reader for this one. Let's see. Elizabeth B., go ahead and read. Right. So cumulative, right? What does it mean when snow accumulates on a windowsill? What does that mean, guys? Anyone?
Builds up.
Yeah, it builds up. It's like it keeps adding on to what was there before. So cumulative GPA, same thing. It's your GPA from the beginning of time up to now, including now. So that's what cumulative means. It's everything from before up to now, including now. So cumulative frequency is all the frequencies of the classes before that up to and including this class. So let me go ahead and share my screen again. And so what I'm going to do is go over to pull up our nifty little guy here and add in one called cumulative frequency. Cumulative frequency. And that's going to be everything in this class or before. So what's in this class or before? This is the first class, so this is 24. This one, there's 2 in this class, plus 24 in the class before it. So this would be 2 plus 24. Someone see me writing right in here? You can also see it up here, up in the upper kind of leftish corner, yeah. Enter. This class has 2 in it, so I'm going to do equals 2 plus everything that came before. Well, what came before? 26, the cumulative frequency from the class before us. This one, I'm going to put equals this guy plus this one, the one that came, 28, the one that came before. And now I can actually left-click drag. See how I get that little, I have a little hand, I have an arrow, then I have a hand. If I go right on here, I get that little black crisscross. If I'm on there, I can left-click drag, and it'll just copy out the formula that's above it, adjusting for, this one says 2 to the left, plus the one above it. So it's I-27 plus K-26. This one will be I-28 plus K-27, 2 to the left plus 1 above it. So that it's kind of useful. And you'll see at the end, you better have everybody, right? Because how many are in this class or in any of the classes ahead of it? In other words, how many people have drink coffee 365 days or less? Everybody, right? Because I made that 365 and a quarter into 365. Okay, that's cumulative frequency. I'm going to go ahead and make that yellow. The other one we can look at doing is, which we'll talk about later, is cumulative relative frequency. So this is cumulative frequencies on the relative frequencies. So this is accumulation, but not accumulation of the regular frequencies. These are the regular frequencies. These are the relative frequencies. We're going to do cumulative on them. So this is going to be, well, what's the percentage in this class or before? 0.60. What's the cumulative frequency in this class or before? Well, this one plus everything that came before, that one. What's the cumulative in this class? Equals this one plus everything that came before, this guy up here. Right, so how about this one? This one is 0.025. I can do it manually as well, 0.025 plus everything that came before, 0.70. And you can kind of go on like that. So it's everything. It's same as the cumulative, only it's doing it not on the frequencies, doing it on the relative frequencies. And then equals this plus that. And you better end up with 1 or 100% at the end, or else you've done something wrong. In other words, what percent of people drink coffee 365 days or less? 100%, all of them, 1 or 100%. So that's the cumulative relative frequency. Should cover everything that we have talked about so far. I'm going to pop that in here. Cumulative relative frequency. Okay, great. Now we're going to do a little bit of group work again. So nominal or ordinal level data can also be placed in categories based upon a category frequency distribution. So in other words, like religion, shirt color, gender, size of pizza, that sort of thing. So here's an example. Let's get a reader. Jaden R. Go ahead and read first. Okay, so here's our data. So this is, one guy had type A blood, another guy had type B, type AB, and type O. Keep going. On the bottom. Right. So if you go over to your Jamboard, you got to go over to Jamboard 4. The data should show up here in a second. Does the data ever show up in the other one? Oh, there it is. You put in your classes, what your classes are. In this case, it would be blood type is what you'd call those, right? And then you would put in the frequency and the relative frequency, right? So you guys all need to go to Jamboards and do this. So hop in there, do it. And do relative frequency as well, right? Ariana, what room are you in? Group 7, I see it now. Group 7. Can you scan them? No. Yeah, right. Cam scan them. Yeah, so Kristen, that would be a no. Hopefully you got that. Eddie, join the room. LA, join your room. Hi guys, hey, there's only 2 of you in here, because
I don't know why.
no one has buggered out, and I accidentally put C into a different group. Do you guys want to split up and go into 2 different groups, or you guys want to stay together? Or I can leave you guys together and put you. I'm sorry.
And then it sounded just like stay. I mean, it's not really a big issue. We're just like confused because like on the first time, like the first breakout group, like we were all together, and the second one was just like the 2 of us.
Yeah. You know, why don't I go ahead and put you into, I'll put you both into break out group 3, because they're missing somebody too. So just say hi and introduce yourselves, and say Ms. Young added me to your group.
Okay.
Okay, kind of going through everybody's.
And we're back.
We are back. Well done, guys. Good job. You guys have it all done really nicely, really well. Your frequencies, your relative frequencies. Some of you guys had tally, some of you guys didn't. But this is the frequency is the actual number. Right? Tally is optional. Frequency, actual number, and then relative frequency. Great. Now, group frequency. So, let's get a reader for this one. Oh. Sorry, thank you. Well done. I was saying, some of you guys had tallies, some of you guys didn't, but remember the frequencies are the actual numbers. Tallies are optional. You should have the frequency of the actual numbers and the relative frequencies, the percentages. Great. Let's go ahead and have C. Can you go ahead and read this one for us? Start from group frequency.
With frequency distribution are used when the range of the data is large. Data is split into equal size classes, that is class classes no more than 20. Sometimes it will be open-ended on the bottom or top.
Great. Right, so you have to have at least 5 classes, not more than 20. So 5 is the minimum to make it, otherwise they're too clumped up. No more than 20, that gets too spread out. And then you can be open-ended on the bottom or the top sometimes if, you have some crazy outliers. So this is open-ended on the top 70 and above. So it kind of goes on and on forever, open-ended on the top, 70 or more. Eddie, go ahead and read this part for us.
How do you decide how to split them into groups? First, decide how many classes you want. First, your range from the smallest to the largest. Divide this range by the number of classes and round up the next integer.
Integer, yeah.
Integer to see how many values there should be in each class. You need to cover the entire range of values, so better to cover more than your range or less.
Great. So let me ask you guys something. If you read pages 10 through 20, your homework is to read pages 10 through 20. How many pages have you read? So private chat to me how many pages that is if you read pages 10 to 20. How many pages is that? Private chat. How many pages? Your assignment is to read pages 10 through 20. All those pages. So about a third of you are right so far. A little less than a third. Maybe a fourth of you. Interesting. All right, let's take a look at this. Let's count them. Okay, so page 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's 11 pages. count them on your fingers if you're not sure with me, right? Just count them out. 11 pages. 10 to 20 is 11 pages. Because 10 to 19, or think of it like 11 to 20 is 10 pages, and then, or 10 to 19 is 10 pages, and then 20 is one more page. So it's actually 11 pages. Like I said, double check if you want to. But the range is you take the top and the bottom and you subtract them. So how many items you have is really your range plus 1, which is why you always have to round up to the next integer, even if you're on an integer, to make sure you have enough. We'll do an example now. Kate, go ahead and read this for us.
Which part?
The whole thing.
Okay. For example, say I had a bunch of weights of rats and it doesn't matter whether I have measured 5 rats or 500 rats. I only need the range of weights and a number of classes so I can split the range up evenly. I just need to make sure I cover all possible weights.
Great.
The smallest rat is 8 ounces. The largest rat is 20 ounces. What is the range? How many classes do you want?
Great. So how many classes do you guys want to use? Number larger than 5. Someone said 6. That's fine. 6 is fine. What's the range? Okay, so first we have to find our range. Our range is our largest minus the smallest. So our smallest rat is 8. Largest rat is 20. So my range is 20 minus 8. So that's going to be 12. So it means I really have 12 plus 1 items. I really have 13 items. So let's take a look. 6 classes. So here are all my numbers that I need to put into 6 classes. My range is 12. So first, if I just do my range minus number, divide by the number of classes, I'll get 12 my range divided by 6 classes. I get 2. We need to round up to 3, and I'll show you why. You always round up. So if I do 2, then my first class would be 8 and 9, right? 2 items in there. Next one we 10 to 11, 12 to 13, 14 to 15, 16 to 17, 18 to 19. 20 would have nowhere to go. Did everyone see that? So I need to either round up to 3 classes, three items in each class, or we just change and have 7 classes, which kind of makes more sense anyways. You can kind of fiddle with it. So I would make it 7 classes and add another class, 20 to 21. The beauty of it is we're talking again about items that are small ranges, less than 25. Then you can just kind of fiddle with your data and figure out something, find something that kind of fits well and looks good and makes sense. That's a piece of cake. So if your data has a small range, like the range is 25 or less, then doing that is easy because you can just do it and you're, oh, that doesn't look right, and just do it again. That's no problem. Because your range, each class width is only going to be like 2 or 3. When your range gets larger than that, 25, larger than 25, then you can do something else. So, who was I going to have? Who hasn't read in a while? TJ, go ahead. TJ?
Jim Hannon?
Yeah, Jim.
Argument for readability. The goal of presenting data and tables and graphs is to make the data more understandable. If the data has a small range, like the last problem, less than 25, then what range is was 5. But if the range is larger, let's say 45, then 5 classes with a width of 10 is more readable. We will see more of this later today in your lab box.
Yep, and actually it might be tomorrow. But yeah, Jim Hannum is this great guy. He was a actual statistician at Lawrence Livermore Lab for many, many years. He's actually sort of semi-famous in that area. People like outside of here have heard of him. And he taught here after he retired from Lawrence Livermore Lab. He taught here for a bit, and then now he just helps out and volunteers in the math lab just to kind of have something to do and not be bored, and to kind of give back. So he's really great. He helps out with the concurrent support classes, and just does some tutoring and stuff like that, just for free to volunteer and have fun. But at any rate, his point was the whole idea of tables is to make your data more understandable. Your point is to sell something to somebody else or convince them of something. So you want them to be able to understand the point you're trying to make. So what he says is that really you're usually going to have class widths that have, class widths of 10 when possible, because those are just really easy to read, like 10 to 19, 20 to 29, 30 to 39, 40 to 49, right? That's kind of easy to wrap your heads around, and really for people, easy for people to kind of see. So typically, if your range is large enough, like, more than 25, then you're going to have, class widths of like, 5 or 10 or 20, something like that, some sort of kind of more manageable numbers that we're used to. So that, again, that's as if you have data and you're trying to create a frequency distribution table, like you made earlier. If you're trying to create one, so like I created one, here, right? If you're creating one. However, if someone has already made one and you're trying to read it, that's a different story. You have no control over it. They've already determined the class width. They've determined everything else. So this is information on figuring out what to do with that at that point. Gavin, go ahead and read.
If you already have a frequency distribution table, the class width can be calculated by subtracting successive lower class limits or boundaries, successive upper class limits or boundaries, upper and lower class boundaries. The class midpoint, xm, can be calculated by averaging upper and lower class limits or boundaries. Right. So the class width, you can find it by subtracting successive lower class limits. So these are lower class limits. You can take two that are in a row from two different classes that are in a row from, one class and the next class. You can subtract them, so 122 minus 61, or you can take the upper class limits and subtract them. And find the class width that way. Either one of those ways would work. Or boundaries. Class midpoints. Midpoints are the number between, in the middle. Anytime you see mid, that means the middle, which means you're going to take the two ends and average them to find the middle. In this case, you're finding the midpoint of the class. So you're going to take the beginning and end of the class, and you're going to average them. So 61, plus 121 over 2. You're going to average them. This is the midpoint. I should just type this. That'd be so much easier. Too late now. And you would get, if I average these two numbers, I get a number in the middle of them. Smack dab in the middle, I'd get 91. So that'd be the midpoint for this one. So hopefully that's clear. Dylan, go ahead and read this one for us. Dylan? Dylan Alexander? Oh, sorry. Doesn't have a mic. Guru, go ahead and read. Right. So these are all lower class limits. They're the lowest number. So like 50 is the lowest number in its class. Its class goes from 50 to 69. 50 is the lowest you can be and still be in that class. Here, 70 to 89, 70 is the lowest you can be and still be in that class. So these are all the lower class limits. Likewise, these are all the upper class limits, right, for each of their classes. Class boundaries. David.
Class boundaries separate the class. To find a class boundary and the upper class and the lower class.
Right. So this is good. So class boundaries. So here is one class, 0 to 60. It's one class, right? Here's another class, 61 to 121. If I were to put them side by side, this is my third class, I need to find the boundary between them. So between these two classes, what's the number smack dab between these two classes? This one ends at 60, this one begins at 61. So between these two is 60 and a half. Does that make sense? Right, I'm averaging the top of this class and the bottom of that class. So 60.5 is the upper boundary for this class, and the lower boundary for that class. Good? So everything that's larger than 60.5 will go into here. Everything smaller than 60.5 will go into there. What doesn't actually matter because these are all going to be whole numbers. You can't have a fraction of a day. But that's how you find the boundaries. You take the upper limit of one and the lower limit of the next one, and you find the number that lies in between them. And that number is going to be his upper boundary and this class's lower boundary. So why don't you guys go ahead and find for me the upper and lower boundary for this one right here. All right, so you need to find the number between these two. That's going to be the lower boundary, and the number between these two, that'll be the upper boundary. I want to take 15 seconds and go ahead and shout that to me. Chat it to me. Private chat it to me. Private chat it to me. Private chat. Don't say it out loud. Okay. Need the lower and the upper for this class right here. Okay, people are pretty much getting it, almost, yeah. Most people are getting it. So yeah, the number between 82 and 83 is 182.5. Oops. And the number between 243, this class, and that class is 243.5. Good. Okay, great. Let me go ahead and clear that. Moving on. IQ scores, so here are the boundaries for each of them. Oh no, yes, these are the boundaries. So 69.5 is his upper boundary and his lower boundary. 69.5 is his upper boundary and his lower boundary. And they're used to separate the classes. But you know that ends up, so then there aren't any gaps between them. They're straight up, which we'll use later when we get to histograms. Class widths, again, you find that by subtracting any of the consecutive lower class boundaries. I pick any two or any two consecutive upper class boundaries. So I can pick any one of these. 70 minus 50, 129 minus 109, 130 minus 110. No matter what, I'm going to get 20 because the class width should be the same between each class. Every class should have the same class width always, or else there's something wrong. And then midpoints, we talked about it already, right? You take the lower and upper class limits and you average them. So I'm going to pop you guys into your Jamboards. Go ahead and fill in your blanks from your word bank. So I'm going to pop that open. Hop on in. Laura, are you here early for the next class? Oh no, you're supposed to be in room 1. You're in room 1. There you go. Yep, I gotcha. You should get it. You should have an option now. They moved it. Oh, I see that added in. Okay. All right. Good. Okay. Yes, we have indeed. Who has not read yet? Zachary S. Go ahead and read for us.
Professor, a
Yes.
lot of us had questions
Oh.
on fourth filling.
On the fourth fill in the blank. What percent is in that class or previous class? So it's kind of like cumulative, only it's with percents instead. So what happens when you do cumulative on percents? Does that, am I muted?
Yeah, I think that.
Am I muted? So you're talking about percent is in that class or previous class. So in that class or previous class it's cumulative, but it's on percents, not on regular frequencies. So what is that one? We're talking about percents. Yeah. So percents is relative frequency, and then in that class or previous class is cumulative, so but cumulative on the percents, so cumulative on the relatives. So it's cumulative relative frequency. Does that make sense? Good. All right, perfect. Good job, guys.
Thank you.
You're welcome. Thanks for asking. I appreciate that. So now, Zachary S., please read for us.
Rules for classes and group frequency distribution. Number 1, there should be 5 to 20 classes. 2, the classes must be mutually exclusive. 3, the classes must be continuous. 4, the classes must be exhaustive. And 5, the classes must be equal width except in open intervals.
Perfect. Let me take this one at a time. Okay, 5 to 20 classes, and we talked about that already. Mutually exclusive means that something can't be in 2 classes. It can't be double counted. So I can't go from 1 to 5 and 5 to 10, because then 5 would be in 2 classes, and that doesn't make sense, because you'd be counting 5 twice. Classes must be continuous. In other words, you can't have gaps in between them. I can't go from 1 to 5 and then go from like 7 to 12, because then 6 would have nowhere to go. Do you guys understand what I'm saying? So you have to count everything. So what we mean by that is we can't go like 1 to 5 and then 7 to 12 and leave no place for 6 to be. Exhaustive means that you have to include everything that's available. So if your data goes up to 20, you can't stop at 19. Your classes have to go all the way to 20. Make sure now all of your data has to be able to go somewhere. You have to have it included somewhere. And then they all have to have the equal width. The classes should all have the same width, unless you're open-ended on the top or the bottom. You know, if you did 70 or more, then obviously that doesn't really have a width. So today, I'm going to change your assignment, and instead your assignment today is going to be quiz chapter 1. So you need to do the quiz we did today. You need to take a picture of that, and page 3 from your notes. So you're going to do page 3 from your notes. You're going to take pictures of both of those, save them as one file, right, as one PDF file. And there's a video on how to save that as one file right down there. But it should be just one file. So go ahead and do that, and that is your proof of participation for the day. You should be able to do that now. And have a good couple days. So page 3, the one we just finished, and then also the quiz for today. We'll see you guys on Thursday. Take care. Bye.